Here are the answers for the section 4-5 homework. We're continuing factoring, but this section introduces a new factoring pattern. The technique is still the same. It's a two-step process. In step 1, look for a greatest common factor. This trinomial does not have a GCF other than 1. Step 2, look for a special pattern. Because it's a trinomial, look to see if it's a perfect square trinomial. The square root of x squared is x, but the square root of 5 would make a decimal. So this is not a perfect square trinomial. Even though it's not a perfect square trinomial, it might still be a factorable trinomial. If this trinomial factors, it will create two binomials. Because this trinomial might be the result of doing FOIL on two binomials where the outer and inner products have combined together to make the 6x term. Realizing that this would come from FOIL helps us to factor it. The x squared comes from the letter f in FOIL, x times x. The positive 5 comes from the letter L in FOIL, the last terms. That is, this number times this number must make positive 5. There are two ways that could happen. The possibilities are a positive 5 times a positive 1, and a negative 5 times a negative 1. To decide which of these to use, we look at the middle term, which is the result of combining the outer and inner products from FOIL. Let's combine 5 and 1. That makes 6. But if you combine negative 5 and negative 1, that makes negative 6. Our middle term is positive, so we want to use the positive 5 and the positive 1. Let's fill them in the parentheses. We have factored this trinomial. It is equal to the product of these two binomials. Number 3. This is a trinomial, but it's not a perfect square trinomial because the last number is not a perfect square. Maybe it's still factorable. If so, it will make two parentheses. N times n is our n squared. Now let's consider how the last number could be positive 6. There are different possibilities. 6 times 1, or negative 6 times negative 1, or 3 times 2, or negative 3 times negative 2. Let's combine these together to see which pair of numbers will create positive 5n. 6 plus 1 makes 7. Negative 6 and negative 1 makes negative 7. 3 plus 2 makes 5, and negative 3 plus negative 2 is negative 5. Our middle term is positive 5n, so it's the 3 and the 2 that we want to use. Fill in plus 3 and plus 2. Number 5. There is no greatest common factor, and it's not a perfect square trinomial, but maybe it is a factorable trinomial. So two sets of parentheses. M times m is the m squared. Now let's consider what we could multiply together to make negative 4s squared. We know that there has to be an s in both numbers. But what about to make the negative 4? Possibilities are 4 times negative 1, negative 4 times positive 1, 2 times negative 2, or negative 2 times positive 2. Let's combine all these together. 4 and negative 1 adds to 3. Negative 4 and positive 1 makes negative 3. 2 plus negative 2 makes 0, and negative 2 plus 2 makes 0. Look at the middle term. It's positive 3ms. So we want to use this first combination, the one that made positive 3. Fill in a plus 4 along with that s, and over here a minus 1. Number 7, there's no greatest common factor, and it's not a perfect square trinomial, but it might still factor. Put two sets of parentheses, and let's see if we can find pairs of numbers that work out. If we can't, then we know it does not factor. We'll just cross out these parentheses and say, not factorable. Y times y makes y squared. Now, what times what makes negative 12? there are possibilities. 12 times negative 1, negative 12 times positive 1, 6 times negative 2, negative 6 times positive 2, 4 times negative 3, and negative 4 times positive 3. Multiplying all these pairs together make negative 12. Now let's combine them and see which numbers make the plus 4. This adds to 11, and this to negative 11. 6 and minus 2 makes 4, but negative 6 and 2 makes negative 4. 4 and negative 3 adds to 1, and the last one to negative 1. We were trying to make positive 4, so we want this pair of numbers, positive 6 and a minus 2. Number 9, there's no greatest common factor, and it's not a perfect square trinomial. Let's try to factor it using the FOIL method. T times t creates the t squared. What about this times this to make negative 80? We have some choices. There is 80 times negative 1, or negative 80 times positive 1, 40 times negative 2, or negative 40 times positive 2, 20 times negative 4, or negative 20 times positive 4, 16 times negative 5, negative 16 times positive 5, 10 times negative 8, and negative 10 times positive 8. These are all the pairs of numbers that multiply to negative 80. But which pair combines to positive 2? That would be the 10 and the negative 8. So we know we want to have plus 10 and minus 8. We went through a lot of wrong choices to finally get the correct choice. The more experience you have with this, the faster it is to know that it's going to be the 10 and the negative 8 to begin with, without even taking the time to list all these other ones that don't work. Number 11, this is a trinomial, but it's not a perfect square trinomial. We're not used to factoring polynomials that are not in standard form to begin with, that has the highest variable term first and counts its way down to the constant. Let's rearrange this form. Put the negative x squared first, then the negative x, and then the positive 6. Because this begins with a negative leading coefficient, let's factor out a negative sign. We get x squared plus x minus 6. Now look at the trinomial. It's not a perfect square trinomial, but it might still factor using FOIL. So there's the negative, and here's the two sets of parentheses. X times x is the x squared. Now what numbers multiply to make negative 6? We have 6 times negative 1, or negative 6 times positive 1, 3 times negative 2, or we have negative 3 times positive 2. These combine to 5, to negative 5, to 1, and to negative 1. Looking at the middle term, we want the one that is positive 1. So this pair of numbers. Fill in positive 3 and negative 2. Number 13. Let's look at this trinomial. There's no GCF, but it might be a perfect square trinomial. The square root of 36s squared is 6s. The square root of 1 is 1. 6s times 1 is 6s, and twice that is 12s. This is a perfect square trinomial. So one set of parentheses squaring on the outside. Here's the 6s, here's the 1, and here's the positive sign because of that positive sign. Number 15. There's no greatest common factor, and it's not a perfect square trinomial, but it might still factor using FOIL. To make 2n squared, we would need to have 2n times n. To make negative 6, we have some possibilities. 6 times negative 1, negative 6 times positive 1, 3 times negative 2, negative 3 times positive 2. We could combine these numbers together to see what we get. However, this problem has a 2 out here. We have to take that 2 into account when we're trying to make the middle term combine to positive 1n. Which pair of numbers should we try? If we try the wrong pair, we'll just erase it and try again. I'm going to try the 3 and the negative 2. If I put the positive 3 here and the negative 2 here, let's check what the outer and inner product combine to. 2n times negative 2 is negative 4n, and 3 times n is positive 3n. These combine to negative n. The middle does have an n, but it's the plus sign. It has the opposite sign of what we got here. What that tells us is we should have used this pair of numbers, the negative 3 and the positive 2. So let's take an eraser and simply change those signs. Minus 3 and positive 2. Now when you do the outer and inner products of FOIL, it will work out. 2n times 2 is 4n, negative 3 times n is negative 3n, and these combine to positive 1n. Number 17. Let's try factoring this trinomial using FOIL. N times n is our n squared. Now what times what is negative 3,500? One possibility is 100 times negative 35. Another possibility is negative 100 times positive 35. But notice that when you combine these together, you get 65 and negative 65. You don't get negative 20. These numbers are too far apart. Let's think of another pair of numbers that multiply to negative 3,500, but they're only 20 units apart. Let's try 70 times negative 50 and negative 70 times positive 50. 70 and negative 50 combine to 20, and negative 70 plus 50 is negative 20. Our middle term is the negative 20, so it's this pair of numbers we want to use. Fill in negative 70 and positive 50. Number 19. This one has a greatest common factor. All of the terms will divide by 2. So write down 2 and then make a set of parentheses that's large enough to fill in a trinomial. 2 times 6y squared is the 12y squared. 2 times positive y is the 2y. 2 times negative 7 is the negative 14. This trinomial is not a perfect square trinomial, but it might factor using FOIL. So 2 sets of parentheses. We have some possibilities to multiply to make 6y squared. It could be 6y times y, or it could be 3y times 2y. Likewise, there are possibilities to multiply together to make negative 7. It could be 7 times negative 1, or it could be negative 7 times positive 1. We need to try these pairs of numbers and then consider the outer and inner product to make positive 1y. I notice that there's a 6 involved in this pair of numbers and a 7 involved in this pair of numbers, and the difference between 6 and 7 is 1 unit. So I think that using this pair and this pair might work. Let's go 6y times y, and then positive 7 and negative 1. Now test the outer and inner products. 6y times negative 1 is negative 6y. 7 times y is positive 7y. And these combine to positive 1y. And that is what our middle term is. If we had selected wrong, we would simply erase those numbers and try another pair from our possibilities. Number 21, there is no GCF, and this is not a perfect square trinomial. So let's try FOIL. 2 sets of parentheses. M times m is our m squared. Now what times what is 300n squared? They're both going to have an n. Now let's think about how we can make the positive 300. We have some possibilities. 30 times 10, negative 30 times negative 10, But if we combine these together, we get 40 and negative 40. Neither of these are negative 35. However, I do notice something interesting. It's those negative numbers that get me a negative combination. So when I think of other possibilities, I don't need to think about positive times positive. I know they're not going to work. I need to have negative numbers. Another pair of numbers that multiply to 300 are negative 25 times negative 12. But these combine to negative 37. That's close to what we want, but not quite. Another pair of numbers that multiply to 300 are negative 20 times negative 15. These combine to negative 35. And that is what the middle term is. So we know we need to go negative 20 in front of the n and negative 15 in front of that n. Number 23. This is not a perfect square trinomial, so let's try factoring with FOIL. N times n is our n squared. Now we need two numbers that multiply to negative 360r squared. We're going to have an r and an r to make that r squared. Now let's think about what the numbers need to be to make negative 360. One possibility would be 36 times negative 10, or negative 36 times positive 10. When you combine these together, it makes 26, whereas this makes negative 26. Neither of these worked, but it helps me to notice something interesting. Because this middle term is negative, I need a pair of numbers where the larger of the numbers is the one that's negative. That's what's getting me a negative combination. Let's find another pair of numbers that multiply to negative 360. Negative 20 times positive 18 is negative 360. When you combine these together, it makes negative 2. This is not the right combination of numbers because it doesn't make negative 9, but it does give me something helpful. The negative 20 and the 18 are too close together. Their difference is only 2 units, and I need a difference of 9 units. So I need two numbers that multiply to negative 360, but the two numbers need to be farther apart. With the help of a calculator, negative 24 times 15 is negative 360. And when you add these together, it is negative 9. And that's the number that I was shooting for. So I need to fill in minus 24 in front of the r and positive 15 in front of that r. Number 25. All of the terms divide by 6, so there's a greatest common factor. Write down the 6 and then complete the trinomial. 6 times x squared is the 6x squared. 6 times positive 5x is the 30x. And 6 times negative 150 is the negative 900. This is not a perfect square trinomial, so let's try FOIL. X times x is the x squared. What times what is negative 150? We have some possibilities. One is 15 times negative 10. Another would be negative 15 times positive 10. This combines to 5, and this combines to negative 5. Looking at the middle term, we want the one that combines to positive 5. So we don't need to try any more possibilities. We know that it is positive 15 and a minus 10. Number 27. All of the terms divide by 2, and there are enough a's in all of the terms to divide them by a squared. The greatest common factor is 2a squared. 2a squared times a squared is 2a to the 4th. 2a squared times positive 5a is the 10a cubed. And 2a squared times negative 36 is the negative 72a squared. This is not a perfect square trinomial, so let's try FOIL. A times a is our a squared. Now we need two numbers that multiply to negative 36. We have some possibilities. One is 9 times negative 4. Another is negative 9 times positive 4. Before we list any more possibilities, let's see what these combine to. 9 plus negative 4 makes 5, and these add to negative 5. Are either of these correct? Yup, we wanted to make positive 5, so it's that pair of numbers. Fill in positive 9 and negative 4. Number 29, there's no greatest common factor, and it's not a perfect square trinomial, so let's try FOIL. X to the a times x to the a is the x to the 2a. Now we need this number and this number. We know that they multiply together to make positive 2. It could be 2 times 1, or it could be negative 2 times negative 1. Do either of these work? 2 plus 1 is 3, and negative 2 plus negative 1 is negative 3. Which one were we trying to make? We want the negative 3. So it's that pair of numbers. Fill in minus 2 and fill in minus 1. Number 31 will have a GCF because there are enough x's in all terms to divide them all by x squared. Write down x squared. Then we need an x squared here, a positive x here, and a positive 1 here. Let's check if this trinomial is a perfect square trinomial. The square root of x squared is x. The square root of 1 is 1. X times 1 is 1x, and twice that is 2x. But this is not 2x, so it is not a perfect square trinomial. Maybe it factors using FOIL. Let's put the two sets of parentheses and try FOIL. X times x is the x squared. Now what times what is positive 1? It could be 1 times 1, or it could be negative 1 times negative 1. 1 and 1 combines to 2. Negative 1 and negative 1 combines to negative 2. Neither of these match the middle term. This trinomial does not factor. So we want to leave this as our final answer. Just erase this work over here where we had started to try to factor. Number 33, there is a greatest common factor. Both terms divide by 2. So we get 2 times 8x cubed and 2 times negative 1. Now look at this polynomial. Does it fit a special pattern? It's only a binomial. It has a minus, so it's a difference. Is it a difference of squares or a difference of cubes? I think it's a difference of cubes. The cube root of 8x cubed is 2x, and the cube root of 1 is 1. So let's use our pattern for difference of cubes. Smaller set of parentheses, a longer set. Fill in the 2x and the 1 and put a minus sign to match that minus sign. Now build the trinomial from what you put in the binomial. Square this first term, 4x squared. Change to a plus sign. Take the product of those, 2x. Put a plus sign. Now square the 1. Number 35. This has a greatest common factor. Both of the terms can divide by z squared. Z squared times z squared is the z to the 4th, and z squared times positive 4 is the positive 4z squared. Now inspect this polynomial to see if it fits a special pattern. It is a binomial. The only binomial pattern we learned is called a difference of squares. This is not a difference. It is a sum. So that is the final answer. Now number 37. We're back to a trinomial. There's no greatest common factor, and it's not a perfect square trinomial because you can't take the square root of the first term or take the square root of the last term and get a nice result. So let's try FOIL. Let's figure out this number and this number. They must multiply together to make 3t to the 4m. I think one of them will be 3t to the 2m, and the other will be t to the 2m. Make sure you agree that these do multiply together to make this first term. To make the last term, we need two numbers that multiply to positive 3. The choices are 3 times 1 or negative 3 times negative 1. Noticing that the middle term is negative, tells us we want to use the negative numbers. Now, if you only combine these together, it would make -4. But we have to take into account that we have a 3 out at the beginning. Let's try the -3 here and the -1 here and find our outer and inner products. 3t to the 2m times -1 is -3t to the 2m. And the inner product is -3t to the 2m. These combine to -6t to the 2m. That's not what the middle term is. It's -10t to the 2m. So that didn't work. Maybe we should have put the -1 first and the -3 over there. Let's erase and try that. Our outer product is 3t to the 2m times -3, which makes -9t to the 2m. Our inner product is -1 times t to the 2m, which is -1t to the 2m. And when you combine these together, it makes -10t to the 2m. That does fit what we were trying to create. So this is the correct spot to put the -1 and the -3.